Right. Firstly, my apologies. I was stuck in the freeway and therefore could not get you on time, but we are here now and we're going to start with functions. The first graph we are looking at is the parabola. So I just want to give you a little bit background. If we look at the parabola, we have y equal to ax squared plus bx plus c. Now, for us to find the turning point of this graph, we can do it lots of different ways. And one of the ways we can use to find the turning point of this graph, if we got y equal to ax squared plus bx plus c, to find our turning point, we can use calculus, find the derivative, equate to 0, that will give us our x value. Now, if you look at my PowerPoint, the parabola has three forms: y equal to ax squared plus bx plus c. We also see a y equal to a into x minus p all squared plus q, which is your square constant form. And we also have a form y equal to a into x minus x1 into x minus x2. Now, the form a into x minus p all squared plus q, when we have the turning point, or I should say the turning point, p and q represent your turning points. If we got a function y equal to a into x minus x1 into x minus x2, x1 and x2 represent your x-intercepts. So the equation we use depends on what is given. And I think we know the basics, how to find an x-intercept. We let y equal to 0, y-intercept, let x equal to 0. The domain, your standard parabola that we see, x is an element of real. And if we actually look at our range, the range of a parabola would be, is either going to be y less than and equal to the turning point, that is the y value of the turning point, or y greater and equal to the y value of the turning point. And it will be less than when we have a maximum TP. In this case, we see a minimum TP. When you have a minimum TP like this case, then it's going to be y greater and equal to your turning point. Okay, so just to recap that, we're now going to look at our first question that we want to tackle together, which I have done before. I'm going to start with that and then get to some past paper questions. We're going to look at the question here. It says the graphs of f of x is equal to minus x squared plus 7x plus 8. So that's our parabola. And then we have, it says g of x is equal to minus 3x plus 24. They're sketched below. And they go on to say f and g intersect at D. So D is an intersection point. And to find the point of intersection, what we normally do is we will equate both the graphs. It goes on to tell us that A and B are the x-intercepts. So our first question here is to determine the coordinates of A and B. Now to do that, all we have to do, the answer came up, so let me quickly work that out. So if we want to find the coordinates of A and B, remember those are the x-intercepts. And to find the x-intercepts, we're going to equate to 0. So it's a very simple equation, minus x squared plus 7x plus 8, and we equate that to 0. If we do that, we're now solving for x. X squared, we're going to do a sign change. And if we do a sign change, you can from here use your calculator and work backwards. Or you could try and factorize. In my case, I'm going to go the factorization route, which is x minus 8 into x plus 1. And from there, I'm going to get two values for x. X is equal to 8, and x is equal to minus 1. Now, the question is determine the coordinates of A and B. So if we want the coordinates of 8, we can now say the coordinates is -1, 0, and we got 8, 0, because it is the x-intercept, which tells us that the y value would be 0. So there we have our first question. Moving on. We're going to question 2. It says, calculate the x-coordinate of D. Now, D is a point of intersection. So what we have to do, as shown by the PowerPoint, we got to equate both the equations. Now, I'm going to give you some time. I want you quickly to work that out. And when you finish, so that I know you're involved, type me a message on the chat with your answer. So let's give you about 3 minutes to work out the calculate the x-coordinate of D, the point of intersection. I will be waiting for you. So remember, as soon as you solve it, send me a message on the chat, then I know it's time to carry on. Okay, we've got some answers coming through. Well done. Okay, so let's look at if we can confirm the answer with the rest of you. Okay, we're going to bring our x's all on one side and form an equation. And I brought everything on one side. It gives me x squared minus 10x plus 16. I also changed the sides. And then I factorized, and I got x minus 2 into x minus 8. And solving for that, let's go one step. We know x is 2 and x is 8. But remember, 8 is the point B, which is a point of intersection. So D has to be x equal to 2. Okay. The question said find the x coordinate. Therefore, we don't have to actually go and find the y coordinate. So I see some answers coming up. Well done to the gentleman who solved this. I see we have Mr. Suleiman said 8. That's actually B. We are trying to find D, so we would go with x equal to 2. Well done to Mr. Kasimji, giving us 8 and 2, but we got to choose one. I also see Dashwood's got the 2. All right, so well done. Let's move on. Okay, the next question is S is a point on the graph, as you can see, and it tells us that x is between 8 and A, which we found to be 2. So our answer has to run between 2 and 8. The question is, ST is drawn, which is a straight line. It says it's parallel to the y-axis. If it's parallel to the y-axis, that means we have a vertical line that will be perpendicular to the x-axis. And the question says, determine ST in terms of x. So remember, if we're trying to find a length of a vertical line, all you have to do is subtract the y values. But because they said in terms of x, in this case, all you're going to do is subtract the formula. So you will notice on the graph that S is on the parabola. So we can make a statement that ST is actually equal to the equation of the parabola, which is given. And then we're going to subtract T sitting on the straight line, which is given by minus 3x plus 24. And if we solve for that, we actually get ST is equal to minus x squared plus 7x plus 8 plus 3x minus 24. And simplifying that, we will get st minus x squared, sorry, we're going to get minus x squared plus 11x minus, and 24 take away 8 would give us minus 16. And that's what I'm getting for st. Now, because the question said in terms of x, that's what we want. We have a equation where st is equal to minus x squared plus 11x minus 16. And then the next question in question 4, it says calculate the maximum length of st. Now, we're going to use our knowledge of calculus in that one. I'm going to quickly skim through the memo. This will bring you to the point. You can forget all this because I've explained that to you. Okay, so that's what we ended up with, st. Basically, we subtract both the equations. Now, from calculus, to find maximum, we find the derivative and equate to 0. So all we have to do there is say st prime. And the derivative of, remember the word is maximum, key word. In calculus, maximum, find the derivative, equate to 0. And you get minus 2x plus 10, that is the derivative, and you're now going to equate to 0. And that'll give you minus 2x is equal to minus 10. Divide both sides by negative 2, we come out with x to be 5. But the question is to find the maximum length of st. So to find st, I'm going to take the x equal to 5 and substitute in the st formula. Now, just to give you some insight into that, I'm going to give you some time. And once you get an answer, I want you to put it on the chat. So we're going to take x equal to 5, and we're going to substitute in the st formula using a calculator. Once you get the answer, please put it up on the chat. I'll give you about a minute to work that out. I'm getting some answers coming through. I just want somebody else to confirm. All right, well done. I see 2 people have given me 9. So if 2 people have given me 9, we can conclude and say, once you substitute that, the maximum length of st is 9. Well done. All right, let's move on. Okay, we can skip all that because I've done that. So one of the famous questions that boys struggle with in grade 12 is when is one greater than the other, when it's less than, etc. So we're going to look at some of these questions. All right, there are 3 questions I have here. So the first one is, when is f greater? So if they're comparing 2 graphs, when is f greater than g? The question is, when is the f above the g graph? So when is the parabola above the g graph? So if we actually take a highlighter and we try to look at this visually, you will notice that the parabola is above the straight line from that point D, which we know is to be 2, to a point called 8. So quickly, write out your answer in the chat for the first one. I'll wait for you till I get some answers coming through. When is f above g? And the question is for what values of x? I'm getting some answers coming through. Well done. And see me using the wrong sign. If you're using your must in a combination question, your small number will always be on the left and not on the right. Can I have more answers coming up? Okay, so we have two formats. I see some answers are coming up. Well done to the gentleman. I see two answers. Two is very less. Let's wait for a couple more. Okay, so we've got two ways to write this. When you're looking at a combination solution, you always use a less than sign, and your small number is always on the left, so it'll be from 2 to 8. Or you could have used interval notation and said x is an element from 2 running to 8, but not inclusive. So we use a round bracket. Okay, let's get to the next question. So the next question is, when is it greater and equal to? So what changes in the question? If it's greater and equal to, all we have to do now is bring in a square bracket. So we can say a less than equal to sign, or x is an element, and we bring in a square bracket from 2 to 8, because now there's a equal to sign with the greater than, which means inclusive. The 653 want to know is, when is f equal to g? That means they want to know the point of intersection. So where do they intersect? They intersect at this point here called 2, and they also intersect at the point called 8. So that is our intersection points. And I think we've done. So if we use a sign less than, then we would look below, but we'll deal with more questions a little later on that. So let us move on. Okay, we look at the next question. To find the turning point of f. All right, to find the turning point of f, and I'm going to use the calculus method, all right? And remember, the calculus method is to find the derivative equate to 0. I know some of you in grade 11 used x equal to minus b over 2a. That will also be correct. Another way to do it is to find the midpoint of the x-intercepts. So let me give you a couple minutes. I want you to quickly try that out and put your answer in the chat, and then I'll move on. Okay, some of you are asking to see the equation. The equation of this graph was, I was hoping you write it down. F of x is equal to minus x squared plus 7x plus 8. So remember, it wants the turning point. We need the x and we need the y value. Just waiting for a little few more answers. See, one answer has come up. All right, I see some answers coming up there. So, and it seems to be correct. Well done. So for those of you who are still struggling, all we said is to find the turning point, we can find our derivative, f prime of x, and then which is equal to minus 2x plus 7, equate to 0. We get minus 2x is equal to minus 7. Divide both sides by negative. You can use your calculator, and that will give you 7 over 2, which is 3.5. And to find the y value, all we're going to do is take that and sub it into this equation using a calculator. And if we do that, we will get the y value to be 20.25, which gives you a turning point sitting at 3,5 and 20.25. Okay, the next question is to find the domain and range of f and g. So remember, domain is the standard parabola. We can say the domain is x element of reals. And we said in the notes earlier, if it's got a maximum turning point, this graph is going down. We can say y less than and equal to the TP. The y value of the TP. And we just want the y value of the TP to be, it's here, 20.25. And that is our range. Okay, we're ready to move on. All right, let's look at a question together now. Below are the graphs of f of x It says below, which in this case, we can say it's alongside. So there's a graph given f of x equal to x minus 4 all squared minus 9. If I look at the equation right now, what is the turning point? Let's wait for someone to type a message. What is the turning point of this graph? Somebody told me E, but I want the exact value of the turning point. I know it's E, but I need to know what is the value of that turning point. All right, I'm getting some answers. And all of you guys are in grade 12. Unfortunately, 1. Okay, I'm looking at the mistakes. Firstly, the first mistake some of you are making. The question says the word coordinates. Whenever you say the word coordinates, you want to create a coordinate, x and y. If we look at the equation, you change your sign. If it's x minus 4, the x value will be 4, and the y value will be negative 9. So remember, this is a square constant form. I want to rewrite that in the form of y equal to a into x minus p all squared plus q, where your turning point is represented by pq. And we can see it's a 4 minus 9 in this case. The next question is to find, okay, we can put it down here. So the value of E is actually 4 minus 9. The next question here is to find the coordinates of A. Okay, A is the x-intercept. So all we have to do is take that equation and equate to 0. Let me give you some time. Go for it. I'm just waiting for someone to confirm an answer. I see one answer up. All right, I see two answers up. So basically, for those of you who haven't realized this, our equation is, sorry about that. Our equation is f of x is equal to x minus 4 all squared minus 9. So to find the coordinates of A, we know that the y value is 0. So we can say 0 is equal to, and in this case, we can complete the square, which will give us x squared minus 8x plus 16 minus 9. And that'll give us x squared minus 8x plus 7. From here, we can use our calculator and factorize. We will get, sorry about that, we will get x minus 7 into x minus 1. And that will give us two x values. One is 7 and one is 1. But the question is to find the coordinates of A. So A will be the smaller value as 1 comes first, 1, 0. And I see three people actually have confirmed their answer, which is great. Okay, the next question is a reflection question. So the question there is, M is the reflection of C on the axis of symmetry. Write down the coordinates of M. Now, firstly, I just want to explain the question. Before I explain the question, I want you to think about that and maybe give me an answer before we go into discussion. Okay. Waiting for somebody to give me an answer. We're still waiting. All right, just to create some discussion for this question, M is a reflection of C. So we see C here. All right. Now, if we reflect that, that's C. They say you're reflecting on the axis of symmetry. Remember, your axis of symmetry is a line passing through the turning point. So C should be, if we reflect C, place our mirror on the axis of symmetry, is going to move, and that we will call M. Now, C and M will share the same Y value. Now, we know that C is the y-intercept. And we actually worked out the equation in the previous question. So if you want to know what the y-intercept is in this case, all right, we let x to be 0, basically. So if our equation was f of x is equal to x minus 4 all squared minus 9, and if we let x to be 0, 0 minus 4 is negative 4 squared is 16. 16 minus 9 is 7. Or we could got it from the previous when we expanded. So we know the point here for C is 7. So that means we know that the Y value of M is 7. Now, we can do it two ways. So if you look at my diagram, we know the turning point, I just want to write it down, is 4 minus 9. So it means that the x value of D is 4. Now, this point that C is sitting on is on the x-axis 0. So the distance from here to here is 4 units. So we're going to move another 4 units. All right, we're going to add another 4 there. And that takes us to a place called 8. Therefore, we can conclude that m is actually the value 8, 7. You can also substitute in the equation and let y to be 7. That's another way we can actually work that out. Okay, when we expanded the equation in the previous one, when I expanded this, so we would have got f of x, the equation of this one expanded is x squared minus 8x plus 7. Okay, that was the equation. So if we know that the y value is 7, we can equate this to 7 and then solve for x. And that will also work. That's another way to do that. Take our 7s on one side. We're going to get 7 minus 7 is 0. And we're going to get x squared minus 8x. And then we're going to factorize. And we come up with two values for x to be 0 or x to be 8. And we're going to choose 8 because 0 is at C. So there's two ways we can actually work that out. And I see, well, I understand Simbi, he's given us an 8-7 correct for 3 marks. All right, so remember, just write down the equation. We may need it. X squared minus 8x plus 7. We may need it for the next question. So I'm moving on. So it says determine the equation of G. That means they want the equation of the straight line. So remember in the previous question, we did say that that was the value called 7 at C. So we have a point on the straight line. Okay. Now the equation, if we look carefully, we just want to find the equation of the straight line. So the other point that we worked out is quite interesting. If you were following me, our turning point for this that we found out earlier was 4. I just want to make sure and go back. Your turning point was 4 minus 9. So that's your x value and your y. Now, if we trace the E from E to D, so we know the value of D is 4. Sorry about that. Okay, so the value of D is 4. They share the same x value. Now, if y is equal to mx plus c, we know the y-intercept is already 7. So give me the equation. I'll give you some time. I gave you a clue. So basically, y is equal to mx plus 7. I'll give you some time. What we want to do now is find the value of m. Well, you can use a gradient formula, or you can substitute the value of d, the coordinate. Remember, d in coordinate form is 4, 0. So we know the x and if we do it the xy method, we're going to get 0 is equal to m. We don't know m, but we know we're going to substitute the point called d. And that will give us 4m is equal to negative 7. And if we divide both sides by 4, we'll get negative 7 over 4. And that is our gradient, and we can put it together. We will get y is equal to minus 7 over 4 x plus a y-intercept of 7. Another way to work out the gradient, you can actually look at the distance. It's a down line. From left to right, it's a down slope. It has to be negative. So m has to be negative. And because we're moving the change in y, because from our 0 point, the change in y is 7 units. And the change in x is 4. So we can use a gradient formula and get the gradient directly. Okay, let's move on. The next question is to write down the equation of g to the minus 1. G to the minus 1 is inverse. So very quickly, let me give you some time. I want you to go work out your inverse of the straight line equation, which we just found. When you have an answer, you can put it up. Okay, we're finding the inverse. Somebody's asking me a question in the chat. Let me give an answer while you're working out. Will the test out of 50 count for this term? No, it counts for SBA. Your report will only be based on your trial papers. The report we give you in this term is a trial-based report. All right, I'm waiting for some inverses to come up. Okay, I have an answer that's just come up, which I want to say is incorrect on the chat. Let's wait for another answer, give you a little more time. All right, another incorrect answer. So let me work it out. Let me try to work out this difficult question for you guys. Step one in the inverse is to step one in an inverse is to swap x and y. So we're going to rewrite that equation as x. Actually, let me change my color pen as well. So we're going to say x is equal to, where you see a y, we're going to make that x. Where you see a x, you're going to make that y, which is a minus 7 over 4x. So not x, that should be y. Let me just take that out. So where we see a y, we made it x. And where we see a x, we're going to make it a y. That'll be minus 7 over y plus 7. Bring my color back to blue. So we want to now make y the subject of the formula. So we're going to bring it on the left. It's going to be 7 over 4y is equal to minus x plus 7. To get rid of the 7 over 4, we multiply by the inverse. The inverse of 7 over 4 is 4 over 7. So y is equal to minus 4 over 7 x plus 7 times 4 over 7. And if you work that out, you can use your calculator. But the 7s basically will cancel off and we'll have a plus 4. So this will be the inverse. We can write this in inverse notation if minus 1 of x is equal to minus 4 over 7 x plus 4. So if you look at the chats, we did get an answer come up which is correct by Mr. Suleiman. Well done. Okay, I think the first two answers were incorrect. I hope you found out where you went wrong. So let's move on to the next question, and I want to give you 2 minutes to try and. Somebody asked me in the chat, is there a mistake with the question? No, there's no mistake. That is the question. It's quite an interesting, it's for 4 marks. So you can see this is more on a level 3, level 4, the higher order question on 4.6. So let me give you about 2 minutes. Try it out, put some answers up. Don't be afraid to put up answers. This is a learning experience. And that's how we grow. Called a growth mindset. We try, if we get it incorrect, it's fine. And that's how we grow. So I'd like to see some answers come up. Okay, what we need to know for this question, that in 4.2, we found the value of A, to get you started, just to remind you, and the value of A was 1. We also find the other, we didn't write it down, but when we factorize, we got 1 and 7 in 4.2. So those two values are very important to us, okay? The 1 and 7. I want to make a note of that. So remember the value of A was 1 and the value of B was 7. Okay, from there, that will help us. All right, let's look at the question. I see your answer is very close, just come up. So let's try and understand this question. You want to know when is x times f of x less than and equal to 0. Now, less than and equal to 0 means when is it negative, right? And when is it equal to 0? So looking at this question, in maths, for us to produce a negative, you can take a positive times a negative will give you a negative. Or you could have case 2, where you have a negative times a positive will also give you. So I'm going to take the first case. We want to know when is x positive. Now, if you look at it, if we look at this graph, so on the right, x is positive. So you must be wondering, what do I mean by the right? Okay, I just want to get an highlighter out quickly. Okay, so if we look at our x-axis, on the right, the x-axis is positive, on the left, it's negative. So if I look at the first case, we know on the right, x is positive. So we got on the right, x is positive. So at the same time, when is the graph negative? Now, for a graph to be negative, it has to be below. For a graph to be negative, it's below the x-axis. So looking at this graph, so this is when the graph is negative, but at the same time, so it's negative, but at the same time, the x value is positive. So there's our first answer, as you can see in the graph. So our first answer will be x. First answer is saying x will be an element. We're running from 1 and we're going to 7. Now, because it's a less than and equal to, we'll have an inclusive or a square bracket. Another way you could write that down is x is less than or equal to 7, bigger and equal to 1. So we've got two options to write that down. Then we look at the second scenario. When x is negative, so x is negative on the left. But when x is negative, we want the graph to be above the x-axis. So we're looking on the left, and you'll notice if we look on the left, the graph, oh, wrong graph I'm looking at. The graph, okay, let me take that out. I'm looking at the parabola. Okay, I just want to erase that. So if we look at the parabola, it's always positive. Okay, it's always above the x-axis. So, and x is always negative, as you can see. So x is always negative on the left, and it's always above, on the left, above the x-axis. So that means from 0 to negative infinity is our answer. So there's two ways we can write that down. We can either say x is less than and equal to 0. That's one way. Another way we could say x is an element from negative infinity running to 0. We can't include, sorry, negative infinity. I wrote 8 there. Let me just change that. So I said from negative infinity, you can't include negative infinity. Nobody knows where's negative infinity. And we're stopping at 0 inclusive because it's got an equal to sign. So that is how we come up with the answer for 4 marks. So this part here will carry 2 marks, and one of these will carry 2 marks, and you got your 4 marks. Okay. So that was a very, very interesting question, a little bit on a higher order. Okay, so we're going to move on now to the next question. All right, so there's another question, and you'll notice in this question here, okay, I just want to scroll to see if I can get another question before I go there. Okay, let's try this one first. It's quite an interesting question, okay? And the reason why I want to do this one is you'll notice now that the x-intercepts are given. Okay, so we're going to go with this one. All right, I'm hoping you're going to read. Okay, so the graphs, the question says ax squared plus bx plus c, a is not equal to 0, and they gave you a g of x, which is a straight line, and d1 minus h is a common point. Looks like a tangent. All right, it is a common point, 1 minus 8. And it tells you that f intersects the x-axis. So we have an x-intercept of -3, and we have an x-intercept of 2. Well, they do tell us that g is a tangent. They confirm that. And then you want to know for what values of x is f of x less than and equal to 0. So 6.1. Can we have some answers come up? Okay, for which value of x is f of x? If we're talking about a graph being less than or equal to 0, it means when is the graph negative? And remember what we said earlier, it will be negative when it is below the x-axis, all right? But they also got an equal to sign, so it must be inclusive. So if we look at the graph and we highlight when is this graph negative, that's below the x-axis. So we're running from -3 to 2 inclusive. So here we have our first answer. Our first answer is x is an element running from -3 to 2. We're going to have a square bracket, or we could write it as x less than or equal to 2, but greater than or equal to -3. And I see some answers come up there, -3 to 2 inclusive. So that's quite good. Right, the next question is what I'm really interested in now. Calculate the values of A, B, and C. And you'll notice that A, B, and C is the coefficients of x in the formula. In other words, what they're trying to tell us is find the equation of the parabola. Now, to find the equation of the parabola, we've got to look at what's given. So if the x-intercepts are given, we're going to use the formula y is equal to a into x minus x1 into x minus x2. So earlier I said x1 and x2 represents your x-intercepts. So you should be saying y is equal to a. The first intercept is -3. So x minus -3 gives you x plus 3. And the second one is x minus x2, which is a x minus 2. Now, our job here is to find a. So to find a, I have to sub a point. Looking at the parabola, now we can't use -3 and 2, it's used. So the point that we're going to use is a point called D, which has an x value of 1 and a y value of -8. So let me give you some time, sub that in into your equation, and that will give you a. And once you got it, you can put your answer up on the chat. All right, we got some answers coming up. Let's confirm. So we said we're going to use a point called D. The y value is -8 into a. X value is 1 plus 3. X value is 1. And if we work that out with a calculator, 1 plus 3 is 4. 4 times -2 is give you a -8a. And if we divide both sides, we get a to be negative. Oh, sorry, I made a mistake there. Okay. 1 minus 2 is -1. Sorry. 1 plus 3 is 4. And 1 minus 2 is -1. That'll give you -4a. Change that. When you get -4a, divide both sides by -4, we should get a to be 2. Now, if a is 2, we're now going to sub that into the equation. And going back to this step, we can now put in our a and say y is equal to a, which is 2 into x plus 3 into x minus 2. And then we're going to work that out using FOIL. We're going to get x squared. 3x minus 2x will give us an x. And you're going to minus 6. And we're going to multiply by 2. That gives us 2x squared plus 2x minus 12. And now that we got our form, the value of a is in front of x squared. So that's our a to be 2. The value of b is in front of x. And the value of c is our constant, which is negative 12. And that gives us a, b, and c. So I see some answers come up. Well done. We saw a c of being minus 9. Confirmation, I saw c to be minus 12. Okay, let's move on. So let's get that equation. Just write it down. The equation of this parabola before we move on is 2x squared plus 2x minus 12. We may need it for the next question. Okay. So we got our equation. Everyone's written that down. And now we're moving on. 6.3, determine the coordinates of the turning point of F. So I'm going to write down the equation. If you didn't take it down, remember the equation was y is equal to 2x squared plus 2x minus 12. So to get some practice on calculus, we're going to find the derivative. Sorry about that, y prime, which is, it is jumping a little. Okay, we're going to get y prime. Which is equal to 4x plus 2. And we're going to equate that to 0. And that gives us 4x to be minus 2, giving us x to be minus half. Okay, so that is the y value of the the x value of the turning point. And to find the y value, we're going to take this and substitute it into the original equation, the y equation. So very quickly, when you get it, give me an answer using a calculator.
Negative 25/2.
Okay, I got one answer that came up on the chat. Unfortunately, that answer is, I've got two answers, two different answers. So if you substitute on a calculator, just to confirm that answer, I'm getting minus 12.5 or minus 12.5. I see in the chat we got two answers. Okay, so I'm going to go and make sure with my calculator, and if you substitute that, I'm getting minus 12.5 or 12.5. Okay, Mr. Dashwood, just check your 10.5. It should be minus 12.5. Okay, make a note of the answer. We're now moving on. Write an equation of the axis of symmetry of H. If H of X is equal to F of X minus 7, a little higher order question. So remember, they want us to write on the axis of symmetry. Now, in the graph that we have, in the previous question, we worked at the turning point. So I'm going to write the turning point. The turning point there was minus half. That's the x value. And a minus 12.5. Now, we're interested in the x value because the axis of symmetry cuts to the axis of symmetry is a line that cuts to the x value of the turning point. So we know this x value here from the turning point is minus half. Okay. So the question now is write down the equation of the axis of symmetry of H. Now, what is happening to the graph? X minus 7 means the graph is moving 7 units to the right. Okay. Because X is equal to 7. And the plus 2 means the graph is moving up and down. So the plus 2 means that we are moving 2 units up. Now, that's not going to affect our axis of symmetry. Only the right movement affects the axis of symmetry. So this axis of symmetry, if it moves 7 units to the right, so we're going to add 7. All right. So our new axis of symmetry will actually be x is equal to, from minus half, all we're doing is adding 7. And that should give us 6.5. And that will be the equation that we are actually looking for. Some of you might say it's 13/2. Okay, the last question there, maybe not last, on this page, calculate the gradient of G. So this is our straight line. Let me give you some time to try and think about it. What will be the gradient of G? As soon as you got it, put it on the chat. Yeah? All right, so to understand this question, we don't have 2 points, so you can't use y2 minus y1 is over x2 minus x1. But the key is tangent. So if the straight line here is a tangent, we got the equation of f. Remember in our equation of x that we found, f of x was 2x squared plus it was 2x squared plus 2x minus 12. Now remember that the derivative is actually the gradient at a point. So we have the point to be 1. So if we find a derivative here, we're actually finding, okay, before we put down m, let's find a derivative. F prime of x is equal to 4x plus 2. So remember that we are saying that the gradient is the derivative at the point. So we can now substitute a point called 1. So our gradient is f prime of 1. Putting 1 here into this derivative equation, and that'll give you 6. So that is our gradient, which is the derivative at the point x equal to 1. Okay. All right, let's move on. Okay, we're going to take a 5-minute interval. I'll leave this on. If you want to carry on, just to a couple minutes for you to have a stretch break. So I know to go to 2 hours in a stretch. So 5 minutes I'm giving you, get a cup of water, whatever you want. And then in 5 minutes time, we'll carry on. If you want, you can start this question. Actually, I don't want to start this question. Sorry. This one, I haven't come to the hyperbola. So I want to stay with parabolas. Okay, this is the question I'd like you to try out while we have a 5-minute break. All right, for those of you just joined us. Okay, so they gave us the equations and they say to use the graphs to determine the values of x for which f of x is equal to g of x. So they want to know the points of intersection. All right, so that one is quite easy. And I see some answers coming up. Well done. So the first one, we can see they intersect at -2 and 4. So there's our first answer. X equal to -2 and x equal to 4. Well done. Okay, we go to the second question. They want to know from us, when is f of x over g of x greater and equal to 0? Can we have some answers on that one coming up? Okay, so in that question there, remember greater than 0 is positive. So in maths, a positive over a positive will give us a positive, case 1. Or we could have a case 2, a negative over a negative. So in other words, we want to know is when is the f graph positive and the g graph positive at the same time, which means we need to look above the x-axis. So if we look, both graphs are positive above. So you can see from, let me get a highlighter to illustrate that. So the f graph is above the x-axis from -2 to 6. And if you look at the straight line from 2, it's always positive. So our answer would be, the first answer there would be from -2 to 6. And because it's got an equal to sign, we'll have to use a square bracket. And there's our first answer. X is an element. The second scenario is when are both graphs negative at the same time or simultaneously. So we need to look below the x-axis. So if we look below the x-axis, that's negative. And you notice the straight line is also negative. And if we look at the other side from 6, and you'll see that the parabola greater than 6 is negative, but the other graph is positive. So there we have, that's negative and that's negative. So negative over negative is positive. So our answer for the second scenario would be from -2 to negative, or sorry, from negative infinity to -2. In other words, from x less than and equal to -2. Or you could say from -infinity to -2. And square bracket on the -2, and we can say x is an element. And that is our answer we're looking for that question. I see some of you gave me an answer of -2 to 6. Well done. But you left out the negative infinity to -2. Okay. So and now I want to go to the last question, which requires some knowledge on calculus. All right, so if we go to the last question, sorry, I just want to. Okay, so if we look at the last question, sorry, my PowerPoint is just jumping there. And the last question wants to know, when is f prime of x times g of x greater than or equal to 0? We're going to put that question on hold till we get to calculus, all right? So when you do some calculus, we'll come back to that question. So I want to now move on. And open the next presentation. Okay, I'm assuming you can now see my screen. And we're going to look at the next graph while we have some time. It's called the hyperbola, which is quite an easy graph actually. So we're going to quickly go through some things. I did do this with you the last time, but just to revise before we go to the past paper questions. So if you look at an equation, y equal to minus 6 over x plus 3 plus 2. So this is our hyperbola equation. The negative tells us a story, which normally would be a negative will run in the second and the fourth quadrant, but the graph has shifted. The plus 3 and the 2 will have something to do with the asymptotes. So if we look at this question, the vertical asymptote here, can I have an answer? What is the vertical asymptote? A vertical, and we can see it in the graph, it comes out, you change your sign, x plus 3, x will be minus 3. Okay. So the next thing I want to look at is okay, if we look at this equation, if it was a general equation, x equal to p gives you the vertical asymptote. We're looking for a horizontal asymptote, and the horizontal asymptote is represented by 2. So we got y equal to 2. And in this form, it will be y equal to q. We move on. We're looking at the range and the domain of this graph. So your range is referring to your y. Y is the element of real, but y not equal to the 2. If we're looking at the domain, x is an element of reals, except for x not equal to the x asymptote, I'm going to call this, which is minus 3. And you see I'm also representing in its general form. If to find the x-intercept, you let y to be 0. And to find the y-intercept, we know we must let x to be 0. Okay, we look at that more when we get to a past paper question. Okay. And I just want you to watch this because it shows you how the graph transforms. So we start with y equal to a over x. If we move it 3 left, then the equation becomes x plus 3. Because we change the sign. That's left means negative 3. If we move it 2 up, then the graph becomes a over x plus 3 plus 2. And to find a, we got to sub a point in. And the only point given in this graph here is 0, 0. You can see that the hyperbola passes through a point 0, 0. So if we use that, if we sub in 0, 0, where there's a y, we put 0, x is 0, we can solve that equation. A over 3 equal to minus 2, cross multiply, a is equal to minus 6. And that actually gives us the equation minus 6 over x plus 3 plus 2, showing you the transformation from a over x and how it has been transformed, shifted left 3 units, moved up 2 units. Okay, so one of the things that we talk about is in a hyperbola always is an axis of symmetry. And the equation of an axis of symmetry, basically an axis of symmetry is a straight line that cuts a graph into two. So we have a positive gradient, that's axis of symmetry. See, we've got two parts. And then your gradient of that will always be m equal to plus 1. Okay. So can you see I represented m or substituted m to be 1? And to find c, you'll sub a point at the line. The line will always pass through where the asymptotes meet, the point of intersection. In this case, it is minus 3, 2. So all we have to do is sub in our minus 3, 2. And that allows us to find c to be 5. And therefore, your equation will become y equal to x plus 5. So this is the positive, a gradient that is positive, axis of symmetry. In other words, an increasing function. But we can have an axis of symmetry that also looks like a negative. It's coming down. So your gradient on the negative line will be m equal to minus 1. And once again, we'll sub minus 3, 2, which we've done. And that helps us to find c to be minus 1. And we come up with our equation, which is y is equal to minus x minus 1. So that's how we find the axis of symmetry of the hyperbola. Okay, so we look at transformation now. So let's look at the first case. If h is equal to f of x plus 3, which means all we're doing in the first case is we're taking our equation and we're moving it up 3 units. So all we have to do is say add 3 to that. We're adding 3, and then your equation becomes, we skip that. Sorry, I think I should do that. So our new equation here would be, if we add 3, it'll be minus 6 over x plus 3 plus 5. In the second one, wherever we have x, we are replacing x with x minus 2. So if you actually want to know what we're doing there, we are basically saying h of x, actually this won't be f, this will be h of x. That's a transform graph, would be minus 6 over, where you're going to x, you're going to replace it with x minus 2. And then you can simplify that. Okay. The next one, the transformation is the f of x is negative, which means that the whole equation needs to change its sign. So we put the minus in front. So transferring a negative on the other side means change of sign. So that would become 6 over x plus 3 minus 2. The last one is, where does the x, you will now replace your x with negative x, so which will give you minus 6 over minus x. Sorry, that moved too fast. Minus 6 minus x plus 3 plus 2. So we're working from that, and where we saw the x, we proved it to be negative. So just to show you on the PowerPoint, taking out all this now. So this looks at the various transformations that can take place in a graph and show you how to find the different equations. Okay. All right, I just want to see that I didn't make a mistake. So we said plus 5, plus 2, plus 3 in the second one, where there's an x, Where there's an x, you replace it with x minus 2. And we know x minus 2 plus 3 is x plus 1. In this one, we do the change of sign. When it's negative, we do a change of sign, that becomes plus, and the plus 2 becomes negative. In the last one, we replace x with a negative x, and we simplify that, and we get a minus 6 over x plus 3 plus 2. And I want to stop there because I'm meeting with you tomorrow night, and I'll sort my sound out. So tomorrow we shall meet, and then we can discuss more on functions. I'm meeting with you at 6 to 8 on functions, and we'll go through the other graphs. The big one is the parabola, which we've covered a lot of ground. So from here, we can look at some past paper questions tomorrow. Any comments before I leave? Okay, so we're going to end there. The session was recorded. We will put the recording up as well. Okay, my link for tomorrow, I have sent on Teams already. I've sent your teachers to put it up on Teams for tomorrow night. The morning session, I'll just have to verify that and make sure it's being sent out. Thank you, gentlemen, for attending and carry on. Tomorrow we'll have sound, so you can ask more questions tomorrow.